Okay, good morning class. So today we're looking at analytical geometry. Okay, so we basically read through this information here. When I did this with my class, we had load shedding at the time. Okay, so I'll just go doing this recording. Just pull this thing up here. Okay, so we're going to look at the examples now for exercise 11.1. And exercise 11.1 is on page 241. Okay. Now, even these examples that we're going through is on page 240. Okay. So again, if you want the full lesson, the link to the full lesson will be found in the description box below. So we're looking at the distance between 2 points. So here we are given an example. We are told S, which is -5 and 0. As you can see, it's marked there S. We've got T, which is -3 and 0, P, which is 0, 1 and 0, and Q with 3 and 0. Are 4 points on the x-axis in the Cartesian plane. The question says determine the length of PQ. So we look at the distance between 1 and 3. The distance, of course, is 2. So it's 2 units. Okay. What's the distance between T and P? So from -3 to 0 is 3, and from 0 to 1 is 1, so it's 4 units. Okay, and now some of you could see it immediately. And then in C, they want you to know what is the length of ST. So that's -5 to 3, -3 is 2 units. Remember, length is never negative. Okay. So from here we can see the rule that we're going to take the bigger one, in this case here, the larger number, which is 3, and you minus it by 1, which gives us 2. In the next one, for TP, I'm going to say 1 minus 3. So I take the bigger number minus the smaller number, which gives me 4. And then ST is going to be, as we know, -3 is larger than -5. So -3 minus -5 is going to give you an answer of 2 units. Okay. Let's look at the next example. It's also on page 240. We are told that A, which is 2 and 2, this makes it a bit smaller. We are told that A, which is 2 and 2, B, which is 2 and -1, and C, which is 2 and -3, are 3 points of the Cartesian plane. Let's calculate the length of AB. What do you notice here? That the points are basically collinear. It lies on the same line, and it lies on the line x is equal to 2. As you can see, all the x values are 2. The x values are constant. So the question says find the length of AB. So what's the length from there to there? Of course, it's a moving horizontal movement. Sorry, a vertical movement, so it affects my y. So from 2 to -1. So firstly, from 2 to 0 is 2, and from 0 to -1 is 1. So what is that distance? So AB is simply going to be 3 units. Let's look at B. Okay. In B, they want to know the length of CA. So CA is from that point there to this point. So firstly to 0, it's going to be 2 units. As you can see, there's 2. And from 0 to -3 is 3 units, which gives you 5 units in total. Let's look at C, which is BC. In BC, BC is here from there to there. So from -1 to -3, I'm moving down 2 units. Okay. So not always we're going to have a diagram. Okay. So what we've noticed, or the rule that we can pick up here, is to, for the length of AB, it's simply the top one, which is 2 minus -1, becomes +1, which is 3. For CA, it's going to be the larger one, which is 2 minus -3. As you can see, the y value there is -3. So it's 2 plus 3, which is 5. There's the same value there. And for BC, again the top, the larger number, which is -1, minus the bottom number, which is -3, which in turn gives you +3, which is no. So yeah, there's -1 minus 3, which of course is +2. Okay. So with that, you should be able to do exercise 11.1. So at this point, I'll stop the video.